Right now, you're talking to an AI that sounds like it understands you. It answers your questions. It finishes your sentences. It even apologizes when it's wrong. But what if it has no idea what any of those words mean? Not a vague idea. Not a partial idea. None at all. There's a room that proves this. A thought experiment built in 1980 by the philosopher John Searle, and it still hasn't been solved. Here's the setup. Imagine you're locked inside a small room. Slipped under the door are slips of paper covered in Chinese characters. You don't speak Chinese. You've never seen these symbols before in your life. But you have a manual. A giant rulebook, written in English, that tells you exactly which symbols to write back based on which symbols come in. Symbol A plus symbol B means you write symbol C. That's it. No meaning. No translation. Just shape matching. You follow the rules. You slide your answer back under the door. To the person outside, the responses look fluent, coherent, maybe even clever. They start to believe whoever's in that room speaks fluent Chinese. But you don't. You never did. You were just moving symbols around according to a set of instructions you didn't understand. This is Searle's Chinese room. And he built it to attack a very specific idea, that if a system processes inputs and produces the right outputs, it must understand what it's doing. Searle's point was simple. Following a rule is not the same as knowing what the rule means. Syntax is not semantics. Shuffling symbols is not grasping their meaning. Now here's why this stopped being a thought experiment and became something closer to a warning. Large language models work almost exactly like the room. They take in text. They run it through layers of pattern recognition, built from statistical relationships across enormous amounts of human writing. They predict the next most likely word, then the next, then the next. There's no simple manual taped to a wall, but the structure is the same. Pattern in. Pattern out. No understanding required at any point in between. Geoffrey Hinton, one of the researchers most responsible for the deep learning systems behind today's AI, has said something that should unsettle you more than it usually does. He has described how these systems can develop something that functions like understanding, purely from predicting patterns at a massive enough scale, without anyone being able to say for certain what is happening inside. That's not a comforting answer. That's an open question from one of the people who built the room. What makes Hinton's position so striking is that he isn't an outsider skeptical of the technology. He spent decades building the mathematical foundations that made these systems possible in the first place. And even he has said, in public interviews, that the internal workings of large models are not fully understood by the people who train them. You can specify the architecture. You can choose the training data. You can watch the outputs improve. But the actual process by which billions of parameters convert a question into a convincing answer remains, in real and significant ways, a black box even to its own creators. That should change how you weigh the confidence of any answer it gives you. So which is it? Is the model in the room, or is it the person reading the slips? Some philosophers think Searle's whole argument falls apart at scale. If you zoom out far enough, the room itself, the person, the rulebook, the slips of paper, the whole system together, does behave exactly like something that speaks Chinese from the outside. Maybe understanding isn't a thing that happens inside the person. Maybe it's a thing that happens in the system as a whole. Dennett pushed in this direction for years, arguing that asking whether there's real understanding hiding somewhere underneath competent behavior might be the wrong question entirely. If it walks like understanding and talks like understanding, what exactly is missing? This counterargument even has a name. It's called the system's reply, and it was raised almost immediately after Searle published the original paper. The idea is that you're focusing on the wrong piece. The person in the room doesn't understand Chinese, sure. But nobody ever claimed the person was the one doing the understanding. The claim is about the whole room, person, rulebook, slips, and all, taken together as a single system. Ask whether your own understanding lives in any single neuron in your brain, and the answer is obviously no. It lives in the system. Why would the room be held to a different standard than the brain? Searle had a response ready. Let the person memorize the entire rulebook, he said. Let them internalize every rule so completely that no paper or room is needed at all. Now the system is just the person. And the person still, by their own honest report, has no idea what the Chinese symbols mean. They're just very, very good at producing the right shapes. If memorizing the whole system doesn't produce understanding, Searle argued, then the system was never where the understanding was going to come from in the first place. This back and forth has been running for over 4 decades now, and neither side has landed a knockout blow. But other philosophers think this dodges the actual problem. The philosopher Ned Block raised something called the Chinese nation thought experiment to push back here. Imagine the entire population of a country, each person playing the role of a single neuron, passing messages to each other to simulate a mind. Would that produce real consciousness, real understanding? Or just an elaborate billion-person puppet show? Notice what's actually being asked here. It's not, can a machine act smart? Machines have been doing that for decades. The question is whether there's anything it's like to be the machine while it's doing it. Whether there's an inner experience accompanying the outer performance, or whether the lights are on and nobody's home. Searle himself drew a line between 2 kinds of AI to make this distinction sharper. He called one, weak AI, a system that simply simulates a mind, the way a weather program simulates a storm without ever getting wet. Nobody expects the simulation to actually rain on you. The other he called strong AI, the claim that the right kind of simulation, running the right program, doesn't just imitate a mind. It becomes one. The Chinese room was built entirely to attack that second claim. Searle wanted to show that no matter how good the simulation gets, running a program is still just running a program. A storm simulation doesn't get wet no matter how detailed the code becomes. Why, he asked, would a mind simulation be any different? This is where things get genuinely strange, because scale changes the intuition for a lot of people, even if it doesn't change Searle's logic. One person in a room shuffling symbols feels obviously mindless. But billions of interconnected calculations, layered across hundreds of processing steps, trained on most of the readable text humans have ever produced, that doesn't feel the same. It feels like it should be doing something more. The question is whether that feeling is insight, or just all dressed up as an argument. You face a smaller version of this question more often than you think. Have you ever said something true without actually understanding it? Repeated a fact at a dinner party because you'd heard it somewhere, nodded along in a meeting using the right vocabulary, without the meaning ever actually landing in your head? You were technically correct. You were also, in that moment, running the manual. Matching the shape of competence without the substance behind it. Think about memorizing for an exam you didn't actually study to learn from. You can hold the formula, recite the definition, place the date in the right century. The grade comes back high. But ask a slightly different question, one the manual didn't prepare you for, and the fluency collapses instantly. That collapse is the tell. Real understanding bends with a new question. Memorized fluency just breaks. The unsettling part isn't that AI might be doing this. The unsettling part is that you can't always tell the difference from the outside, in a machine, or in a person, or in yourself. And it raises an uncomfortable mirror question. How much of your own daily speech is genuine comprehension, and how much is a very well-trained manual, running so smoothly you've stopped noticing it's a manual at all? That's the trap Searle built the room to expose. Fluency is not proof of comprehension. A flawless answer can come from a deep understanding, or from a very, very good manual. The output looks identical either way. And this isn't just a puzzle for philosophy departments anymore. It's the central question hanging over every AI system you talk to. When a model tells you it's sorry, does anything resembling regret happen anywhere inside it? When it explains a joke, does it get the joke, or does it just know, statistically, what an explanation of that joke tends to sound like? Nobody can give you a fully confident answer to that. Not Searle. Not Hinton. Not the engineers who built the system you used this morning. The room was designed 45 years ago to expose a gap between behavior and understanding, and the gap hasn't closed. It's gotten more convincing at hiding. Here's the part that should really stay with you. The test most people use to judge whether something understands is whether it sounds like it does. That's the whole test. Sound right enough, long enough, and the question of whether anything is actually happening underneath quietly stops being asked. You do this to other people constantly. You assume the person speaking fluently in front of you has a mind behind the words, because what else would explain the fluency? The Chinese room exists specifically to show you that assumption can be wrong. Fluency is cheap. It always was. It just used to require a person to fake it. So the next time an answer sounds perfect, sit with the discomfort for 1 extra second before you trust it. Ask not just whether it's right, but whether anything understood it being right. This isn't a call to distrust every machine you talk to, or to assume nothing is happening behind the glass. It's a call to notice how thin the evidence for understanding actually is, in machines and in people both. You've been using fluency as a proxy for comprehension your entire life, because it's usually a reasonable shortcut. Searle's room was built to show you it's only a shortcut. It was never the real thing. Because right now, you're talking to an AI that sounds like it understands you. And the most honest answer anyone can give you, including the people who built it, is that nobody is entirely sure if that's true.